Okay, so now we have the graph of g of x equals ax squared. Notice the difference. There's parentheses now around the a and the x. Okay, so right here, that vertical dilation, that a and x are on the outside of the parentheses, but now we have them inside the parentheses. Whenever you see them inside the parentheses, that is going to be a horizontal, either compression or stretch. But let's talk about it. So the graph of g of x equals ax quantity squared is the graph of f of x equals x squared stretched or compressed horizontally by a factor of 1 over the square root of a. That shows 1 over the square root of a. So it's a little bit different. So if our absolute value of a is greater than 1, then what happens? The graph is compressed horizontally. It's exactly the opposite of the vertical. It's compressed horizontally. Now I want to show you something towards the y-axis. Okay, think of this side of, well, we'll go to this side of the screen. Think of this side of the camera as I'm right up against my y-axis right there, okay? And I'm going to push her, I'm going to compress her towards the y-axis. Notice what's happening. It looks almost like a vertical stretch, doesn't it? It thins out her face. So in this case, when we compress horizontally, and do it in blue, over here, we have the parent function, right? That x squared is just a normal function. When we compress horizontally, it's actually thinning it out, right? It's making it squished in and thin, like this. Poor Edna, she's being all sorts of manipulated, okay? Now, conversely, if that a on the inside of the parentheses is a fraction or a decimal in between 0 and 1, then guess what? The graph is stretched horizontally. So let's look at that. What does stretched horizontally do to Edna? Well, again, if this is my y-axis right over here, then when I stretch it horizontally, right, it's kind of like, it's hard to see a little bit, but it's kind of like that vertical compression, right? That vertical compression that smooshes her down. So is that horizontal stretch doing the same thing. So a horizontal stretch actually widens the graph. It fattens it out. I'm not fat. I'm either vertically compressed or horizontally stretched. That's just what's happening here. Okay, so now let's look. The graph of g of x equals 2/5 x squared. Okay, notice no parentheses. So we know that this is vertical, a vertical dilation. And it said, I believe, 2/5. Yeah, and that 2/5 is right here, which means it's going to be compressed vertically, so it's going to widen out. And it is compressed vertically. Of the graph of the parent function by a factor of, remember, it says it's always going to be factor of the square root of a. So what's the, or not square root, I keep saying square root, I mean absolute value. Absolute value of a, and the absolute value of 2/5 is just 2/5, so it's by a factor of 2/5. Now here's where it gets a little weird, guys, and we'll explain it. Now we see parentheses, so we're talking about horizontal. And it's 1/3, which means it's between 0 and 1, right? So it's stretched horizontally, so it's going to widen it out. So this is a horizontal stretch. Of the graph of the parent function by a factor of, now here's what's going to trip you out a little bit. The factor is actually 3. Remember it said it's by a factor up here of 1 over the absolute value of a. So that would be 1 over 1/3. Remember that fraction bar just means divided by, so this is 1 divided by 1/3. Remember, to divide by the fraction is the same as multiplying times its reciprocal. So 1 times 3 over 1, which is 3. But at the end of the day, all you're going to do is take whatever's inside the parentheses and just flip it. Okay? So it's by a factor of 3. So if instead, if I had g of x equals 3/5 x squared, then it would be by a factor of 5/3. Or if I had g of x equals 5x squared, it would be by a factor of 1/5 because we just flip it, right? So just keep that in mind. All right. Now we're going to end on reflections here. It says the graph of f of negative x is the reflection of the graph of f of x equals x squared across the y-axis. Okay? So if we have x-axis I skipped. The graph of negative f of x squared is a reflection of the graph of f of x equals x squared across the x-axis. So outside the parenthesis negative is across the x, inside the parenthesis negative is across the y. So let's look. The graph of g of x equals negative 2x squared is the graph of the parent function. It's stretched vertically, right, because it's no parentheses and it's greater than 1, so it's a vertical stretch. And reflected across the, well, it's outside the parentheses, which is our x-axis, across the x-axis. The graph of g of x, oh, I see parentheses, negative 3/4 x. Well, first of all, I can tell you this is between 0 and 1, it's a fraction, and it's in parentheses, so a fraction is going to be a horizontal stretch. So the parent function stretched horizontally. Look, I was right. And since it's in the parenthesis, it's going to be across the y-axis. All right, we're almost done here. This last one, we see the negative on the outside. The outside always means the x-axis. So it's the graph of the parent function reflected across the x-axis and translated, let's see, which direction does a plus 2 go? That plus h, remember, that's the friend that makes you look twice, so it's actually not right, it's left 2 units. And this is the friend you can trust, so it's up 4 units. Boom. All right. Okay, look at this graph down here. Which is the equation for the function in the graph shown? Well, I want to start at the bottom here. We see g of x equals 1/2 times x minus 4 squared plus 1. So let's look at that. First of all, it says minus 4, which means that tells us to move to the right 4. So if I have the parent function, and by the way, something about x squared. If I have f of x equals x squared, well, what if I plug in a 1 for the x? So if I plug in a 1 for the x, what's 1 squared going to be? It's going to be 1. What if I plug in negative 1? Negative 1 squared is still going to be 1. So let's put 2 points, one at 1, 1, and one at negative 1, 1. The graph of x squared always goes through those 2 points, okay? So let's just know that. So if I look at this graph right here, so again, from my origin right here, I went up 1 over 1 and up 1 over 1 over here, okay? This tells me to move it where? It says to move it to the right 4, 1, 2, 3, 4, and up 1. And that should be where the vertex is, because we're just moving this vertex right here. Is that where the vertex is of this graph? No. It doesn't line up, doesn't move right. Okay? So, what does this have? This has the wrong shift, right? Now, let's look at this one right here. It says plus 1, which tells me to go left 1. And then it tells me to go down 4. 1, 2, 3, 4. Hey, that's the right start point. But here's the problem. Remember, we don't do anything else to it. So it's just going to be from right here. I should go up 1 over 1 and go through that point, and up 1 left 1 because I'm not stretching or I'm not dilating it. So it would be this graph right here. Does that line up exactly? No. So it can't be this one. It's not wide enough. It's not wide enough. So look at this. I'm going to start off at A. And looking at A, it has a negative in front. Anytime you end up with a negative in front of the x squared, guess what? It's going to open down. This one opens down. Doesn't work. Our graph right here opens up. We need it to open up. So the only one left is B, and let's look at that. Let's prove it. So again, it tells us to go left 1 and down 4, which we've done that. We've proven that's the right spot, right? But then it has a 1/2 here. So they gave us the point 1, -2. So I want to plug in 1 for x and see what it gets me. I would have a 1 for x. 1 plus 1 is 2. What's 2 squared? It's 4. Half of 4 is 2, and 2 minus 4 is -2, which is that point right here it gave us. So we know that B actually works. All right. That is. Make sure you have all this written down. I know that's a lot of information. You have to go back, check out parts of this, ask lots of questions, do the homework. The practice will help. With that said, peace out.